Hello students, my name is Raghuraj sir and we are discussing chapter metals and non-metals. And in that today we are going to discuss chemical properties of metals. This is lecture series 5. We have already discussed introduction to metals, physical property of metals, then non-metals and then physical property of non-metals, and today we are going to discuss the chemical property of metals. So today we will see the chemical property of metals, how they react with oxygen. What is the product when the metals react with oxygen. So let's see that. Almost all metals combine with oxygen to form metal oxides. Almost all metals combine with oxygen to form metal oxides, and they are basic in nature. We'll see it how they are basic in nature in our further slides. And that means, like, if you see the reaction, metal, when it reacts with the oxygen, it gives metal oxide. Let's see one simple reaction. If we see magnesium, when magnesium reacts with oxygen, it gives magnesium oxide. This is simple experiment where you burn magnesium ribbon and you get collect ashes of magnesium ribbon in a watch glass. This magnesium ashes which you have collected in the watch glass, this is the magnesium oxide. This is magnesium oxide. So metals, when they react with oxygen, they give metal oxides, and we saw one example how magnesium reacting with the oxygen gives magnesium oxide, and this is a simple experiment to do that. And there are some others also, metals like copper. So when copper reacts with oxygen, it gives copper oxide. So chemical formula is 2Cu plus O2 gives 2CuO. So this I have already balanced this equation. So this is when copper reacts with the oxygen gives copper oxide. There are some more examples, like we can see aluminium. When aluminium reacts with oxygen, it gives aluminium oxide, and the reaction is 4Al plus 3O2 gives 2Al2O3. So these are the three examples which we saw the reaction of metals with oxygen. The magnesium reacting with oxygen, copper reacting with oxygen, and then aluminium reacting with oxygen, all are forming metal oxides. It forms magnesium oxide, it forms copper oxide, and aluminium forms aluminium oxide. And this you might have seen in your homes. If you can recognize, these are simple chains. When you keep some chains outside, iron chains, they catch rust, and this is how they look like. They form a reddish color on the surface. So this reddish color which has formed, or dust which has formed on these iron chains, is actually iron oxide. And let's see the formation, how it forms. So let us study something about rusting. So first, as we see rusting of iron, this is how it looks like. So now let's see what are the reaction which happens in it. It is basically iron in presence of oxygen and water. In presence of oxygen and water, it forms iron hydroxide. So basically it needs the presence of oxygen and water also. And then this further it dehydrates, and what we get, Fe2O3 dot NH2O, this is known as rust. this is what you see on chains. They form rust by iron when it reacts with oxygen and water. Similarly, not only just iron gets into rusting, even copper also shows this property of rusting, or shows this rusting process. And like iron looks reddish, on from the top when rusting happens, while as copper looks greenish. This is how it looks, copper looks when it is in the rusted form. And the reaction which takes place is copper reacts with all moist air, which is in presence of water, carbon dioxide and oxygen. It reacts in the presence of moist air, and it forms copper hydroxide, and it forms copper carbonate. And this copper hydroxide is called rust, and it is green in color, which you can see here. And it also forms copper carbonate. So again, we'll just see the reaction. You can just see the reaction so that you can memorize it. It's very important. Rusting is asked in exams, so it's very simple reactions. You can just make sure that you write them properly. And the best example, if it comes in the mind of rusting of copper, is actually Statue of Liberty. This is the Statue of Liberty, because it was made from copper. This was it originally used to look like, and now this state is like it has become greenish in color. So why it has become greenish in color? Because of rusting process. So that's how it has become rusted. And further, one more point is in chemical properties is all metal oxides are acidic or basic. This is what we'll try to find out now. Are metal oxides acidic or they are basic in nature? So let's find out. So how to find out? So we have simple test. This is known as litmus paper test, through which we can find out the metal oxides are acidic or they are basic in nature. And how to do that? It's very simple reaction. If we take red litmus and we dipped in the solution, and if this turns blue, then the solution is basic. You can see here red litmus is turns blue, so this means this solution is basic. And if blue litmus paper turns red, then that means the solution is acidic. So it's a very simple test to make sure that we can test the solution is acidic or the solution is basic in nature. If red litmus turns blue, that means it's basic. If blue litmus turns red, that means it's acidic. And how to test it for metal oxides? Very simple. We have already seen a reaction of magnesium with oxygen. It forms magnesium oxide. And this magnesium oxide, we can collect it in watch glass. And this ash, magnesium oxide, we can mix in water. We can mix it in water from a solution and then dip red litmus paper. And if it turns blue, that means metal oxide which we got is basic in nature. Isn't it a simple test? Or you can take even iron rusted iron. You can scrap it and then mix it in solution. Although it may not mix fully, but still you can try, and then you can dip again, same experiment, red litmus, and you can see if it is basic or acidic in nature. Obviously it will come basic, because all metal oxides are basic in nature. All metal oxides are basic in nature. So this is the chemical property of metals. Just to recap, first we saw the reaction with oxygen of metals. As we saw, all metals combine with oxygen to form metal oxides, and they are basic in nature. Now you understand the statement. Then we also saw the reaction metal plus oxygen becomes metal oxide. And then we saw the example of magnesium reacting with oxygen, forming 2MgO, and what is gives, this is the magnesium oxide, which you can collect in the watch glass. And then we saw the example of copper, 2CO plus O2 gives 2CO. And then we also saw how aluminum reacts with the oxygen, 4Al2 plus 3O2 plus 2Al2O3. This also forms aluminum oxide. And then we saw the rusting process. We saw the rusting of iron. And we saw the reaction, 4Fe plus 3O2 plus 6H2O gives 4FeOH whole thrice, which is iron hydroxide, which dehydrates. Basically all water goes away, and it forms Fe2O3.NH2O, which is nothing but a rust, and it looks like this. And then we also saw the rusting of copper, and the chemical equation for that is CuH2O plus CO2 plus O2 gives CuOH whole twice, which is nothing but copper hydroxide, which is rust, and copper carbonate, CuCO3. So my dear students, please note down these reactions which we are writing here on your notepad, and write them so that you can memorize all these reactions. And then we saw the best example for copper rusting is Statue of Liberty. And then we also saw how all metal oxides are acidic or basic in nature. There we understood that all metal oxides are basic in nature. Thank you, students, for your attentive hearing. Thank you, students, for your attentive hearing. Thank you. So you have any doubts, please ask us, and we will be happy to answer you. Thank you very much.